Good day to Dr. Afzan. We are from Group 4 and I'm Woon Shi Yeu.
Hi, I'm Goh Kean Wei.
Hi, I'm Tang Quan.
I am Zhao Tian.
So this video is regarding about our parking system project.
Right, so before anything else, let us do a little bit of introduction to this project. So we are required to design a car parking count system, and we assume that the car park has only 100 parking slots. And when the car park is full will be displayed on the LCD screen. Else, the LCD will display available and the current numbers of cars inside the car park. Now let us move to the code of this project. So we're going to use two libraries, which is hashtag liquid crystal i2c.h and wire.h. These two libraries is used for us to actually use the LCD screen. And then we are going to call the LCD function, and then we are going to declare count equals to 0, entry sensor, exit sensor, car in, car out, and max park, which is the maximum car parking count, which is 100. And then for the setup part, we are going to actually declare LCD backlight on, and then we are going to actually set the pin mode as input. Then as for the loop part, if the car parking count is greater than or equals to 100, then full will be printed on the LCD, or else the LCD will print available and it will detect input from the exit and entry sensor. And then for the next part, if the car in which is connected to the entry sensor, if it's equal to 1, then the car will be close to count plus 1, and then we will have a delay 100 there to actually prevent whenever we push the button, we actually have to only detect it once. And then as for the car out, it's actually the same. Only difference is that whenever car out is pushed, then the count equals to count minus 1, and we also have a delay 100 there. As for the last part, you can see that we actually will print the number of cars available over 100, which is the maximum car parking slots available.
And we are going to show our circuit connection of our project and also the demo on our system. Right, so first of all, this is how our circuit look like. So we have connected the VCC 3.3 volt into this row, right? So the whole row will be 3.3 volt, and then we connect to ground as well for this row, right? And then these two buttons, they are the sensor, and then this is the entry sensor, this is the exit sensor. So basically, this entry sensor is connected with pin 12, right? This is pin 12, and then this exit sensor is connected with the pin 13, right? So pin 12 and pin 13, these two pins, they are input pin. Alright, so let's say for the pin 12, alright, pin 12. So this pin 12 is connected to one side of the button, and then at the same time is connected to the blue LED and also the resistor as well. And then this resistor is connected to ground. Alright, so in this connection, basically we will make sure that this input pin, let's say pin 12 is always connected to ground. Means that the value is always to be 0, and in this case is this condition is applied to the pin 13 as well. Alright, so this is the pin 13 is also connected to the red LED and also resistor. Right, so for another side of the button, we connected it to the VCC 3.3 volt, so that when we press the button, the pin 12, let's say pin 12, will receive 3.3 volt, which is a value of 1, and then once we release the button, it will connect back to the 0. Connect back to the ground, right? So for the LED, it is just for the button indication. It means that when the LED is light up, we just which means we already press the button, right? Same case for the red LED. So this is LCD screen, right? Basically, if we want to print the message on our LCD screen, we have to use the I2C module, right? This is the I2C module, right? So so this is the ground. We just connected it to the ground, right? Connected it to the ground to the breadboard, and then this is the VCC, right? For this case, VCC we have to use 5 volt, right, in order to light up our LCD screen, and then this is SDA, means that serial data, and then for the SCL is serial clock. For these two pins, we just connected to the SDA and SCL on our Intel Galileo platform, right? So basically this is all about our circuit connection. Right, so for the demonstration video, basically we can refer any message on the LCD screen. So this is the number of car that already in our parking lot, and then this is the total number of cars that we can receive or total number of cars can park in our parking lot. So if the car in our parking lot is less than 100, it means that we have the place to be able to park. So the screen will show available. So once the car is enter our parking lot, the entry sensor will be triggered. So we can see that the number of cars in our parking lot will be increased, right? So once the car is entering our parking lot, the number will be increased. So same case for the exit sensor. Once one of the car is exiting our parking lot, the number of car in our parking lot will be decreased, right? Okay, so this is entry, this is exit. So let us go to the condition that where our parking lot is full. All right. Alright, so we can see that now we already have 98 cars in our parking lot. We only can receive 2 more cars. So once two more cars enter our parking lot, right, 1, 2, alright, we can see that the LCD screen means mention that our parking lot is full. Then we can see that number of cars is 100 per 100. So we can see so this entry sensor will be disabled, right? Whenever how we press the button, the number will not increase. So only when we some of the cars are leaving our parking lot, right? So the number of cars will be decreased. In this case, we only can increase the number of cars by triggering our entry sensor, right? That's all for our demonstration.